Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to multiply and divide rational expressions. Our focus on this presentation will be on carrying out these operations on monomial factors. All right, let's take a look at the examples. The instructions are to simplify each expression. Okay? Number one, what if we're given the product of rational expressions, 6 over 7 times 10p to the third over 8. Now what we're going to do first is we're going to decompose composite terms and monomial factors and find the product of the decomposition, okay? So let's start with 6. What is 6 as a product of primes? Factor out 2, you're left with 3. So 6 can be written as 2 times 3, expressed as a product of prime. 7 is just a prime number, so we leave that alone. 10 can be decomposed. 2 goes into 10 5 times. So 10p to the third can be written as 2 times 5. P to the third simply means you write p 3 times. Can we decompose 8? Absolutely. 8 is a composite. 2 goes into 8 4 times. 2 goes into 4 2 times. So the decomposition of 8 using just primes is 2 times 2 times 2. Now we're going to reintroduce this decomposed form of these numbers and monomials back into this product of rationals here and see what happens. Okay. So 6 becomes 2 times 3 divided by 7 times, let's write 10p to the third in its decomposed form. 10p to the third is going to be 2 times 5 times p times p times p. And then 8 can be written as 2 times 2 times 2. All right. Now what we can do is we can reduce and then multiply, or we can multiply and reduce afterwards. So to keep my work organized and avoid making mistakes, I'm going to multiply first and then reduce, okay? So let's go ahead and multiply the numerator. We're going to express it in its factors, in its decomposed state, okay? So 2 times 3 times 2 times 5 times p times p times p. You're multiplying horizontally. And then you have that divided by the denominator, also expressed in it as a product in its decomposed form. So you have 7 times 2 times 2 times 2. Okay, now let's divide out common factors. There are no 7s in the numerator, so we'll leave 7 alone. 2 goes here 1, 2 goes here 1. 2 goes into itself once, 2 goes here 1. Now, the importance of these ones cannot be overemphasized. You always want to put these ones there because they tell you that there's still a number that's occupying the place of the reduced number, okay? So let's go ahead and multiply. In the numerator, what we have is 1 times 3 times 1 times 5 times p times p times p, which is going to give us 15p to the third. In the denominator, 7 times 1 times 1 times 2 is 14. And there goes your final answer. Now, if you have any questions about the steps involved in generating these results, just place your questions in the comment section below, and we'll be more than glad to address your concerns. Now, let's take a look at question number 2. In this case, we're looking for a quotient, okay? 10 over 3 divided by 10x squared over 3. Now, whenever you're dividing, you're going to drop, change, flip, okay? So to drop, change, flip is just another way to divide fractions. When you drop, change, flip, what you're doing is you're multiplying the dividend by the reciprocal of the divisor. and that's equivalent to dividing two fractions. Okay, so this is the dividend, this is the divisor. You drop the first one exactly as it is. You change your operation to the inverse of division, which is multiplication, and then you flip or reciprocate this fraction. You interchange the numerator and the denominator. So that yields 3 over 10x squared. Now we have changed the division problem into a multiplication problem. Now what we're going to do next is we'll proceed to decompose the numbers. We're just going to focus our attention on the decomposition of composites here. Okay, so 3 and 3 are prime, so we'll leave those alone. 10 can be decomposed into 2 times 5. 10x squared, so 10 is 2 times 5. 10x squared can be decomposed. We already know that 10 is 2 times 5, so we just add on the x squared as x times x. All right, so let's go ahead and reinsert those. 10 is 2 times 5 divided by 3 times 3 divided by 10x squared in its decomposed form. All right, so if we do that, we have 2 times 5 times x times x. Now we're going to multiply and reduce. You can reduce and then multiply, you get the same result. Alrighty, so if you multiply the numerator, you have 2 times 5 times 3 divided by the product of the denominator factors in their decomposed state, which is 3 times 2 times 5 times x times x. Now let's divide out common factors. 3 goes into 3 once, 3 goes into 3 once. Please do not forget to place the ones there. And then let's look at the 2's. 2 goes here 1, 2 goes here 1. And then the 5's. 5 goes here 1, 5 goes here 1. Now this is a big mistake most students make. They say the answer is equal to x squared. Do you see why that's incorrect? That is incorrect because in the numerator we have a product of 3 numbers. 1 times 1 times 1. That's the number that holds the numerator position. So you now see the importance of putting that 1 there. So in the event of you dividing all the factors, you still remember that there's still a 1 there that needs to occupy the position of the product of the numerator or denominator. In the denominator position, we have 1 times x, which is x squared. So that is the answer to question number 2. All right, let's take a look at the one more example. We're going to be looking at problem number 3. What if we have the following product? 3b to the second power divided by 7b multiplied by 6b squared divided by 3b. So what we're going to do is we're going to go ahead and decompose the composite numbers. Okay, the only composite number I have is 6, so that can be decomposed into 2 times 3. So 6b squared is decomposed state is equal to 2 times 3 times b times b. All right, so let's write down those these two factors in their decomposed state. We have 3 times b times b. That's divided by 7 times b. And then 6b squared, we have 3 times 2 times b, as we have determined to the right, divided by 3 times b. Now what we're going to do next is we're going to proceed to multiply. Okay, we're going to express the products in its decomposed state, which means we're not multiplying the numbers, we just put in the prime factors next to each other along with the variables. So 3 times b times 3 times 2 times b times b. So let's make sure we have everything accounted for. 3 and a 3, 3 and a 3, BB, 4 B's, 1, 2, 3, 4, and 1, 2. That's perfect. Now let's direct our attention to the denominator. We have 7 times b times 3 times b. Okay, so let's go ahead and cross reduce. Common factors, 3 goes here 1, don't forget the 1, 3 goes here 1, b goes here 1, b goes here 1, b goes here 1, b goes there once, and that's basically it. So let's go ahead and multiply out. B times 3 times 2 is 6b squared, divided by, in the denominator we have 7 times 1 times 1, which is 7, and there goes your final result. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of rational expressions, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about what we covered in this presentation, just place it in the comment section below, and we'll be more than glad to support you. Do subscribe to our channel. We always update math tutorials to our YouTube page on a consistent basis, so do subscribe so you can get updates to those content. More materials can be found on math.serve.com. Thanks again for watching and have a wonderful day.